So introduction investigation, which is steeper and how do you know? So for the two line segments that are given, which one is steeper? The one on the left or the one on the right? Think about it if you're imagining to walk up or down this hill. Well, the one on the right is much steeper. It is much harder to go up the hill of the one on the right, whether you're going up or down. Discuss does direction matter in terms of steepness? What is another word for steepness? So what do you think? Does direction matter? Well, if I look at the one over here, which has a positive slope, and I paste it and I try to rotate it and try to mirror it so that it looks the same. Okay. Well, the steepness of the slope will still be the same, except one will be a positive and one will be a negative version. Okay. What is another word for steepness? Well, think about it if you are skiing or snowboarding. These are words that you might have used before. There's an incline or a decline, or another word for it is slope, which is our Cycle 2 Day 5 lesson. So when calculating the slope or steepness of a line, we need two pieces of information. One, the rise, so the vertical distance between 2 points. The run, the horizontal distance between the 2 points. We use these two information to find the slope. Height or the rise isn't the thing that matters when talking about steepness. The run matters too. So did you draw the rise and run of the following three questions? What are your observations about the steepness of each triangle? So this is how I usually go about drawing the rise and run. I draw by using these blue arrows. So I indicated my rise of 2 and a run of 1, which is from this line segment. So slope is rise over run, and so I have 2 over 1. So my slope of this line segment is 2. When I have a rise of 4 and a run of 2, my slope is again 2 because 4 divided by 2 is 2. When I have a rise of 8 and run of 4, my slope is equal to 8 divided by 4 or is equal to 2. So I'm noticing that in all three cases, my slope is equal to 2 because all of 2 over 1, 4 over 2, and 8 over 4 is equal to 2. And if you notice, if you look in this giant kind of like staircase, I have really 4 of these 2 over 1 ratios. And so that's why we're getting an m equals 2 each and every time. And the main point of this is that it doesn't matter what coordinates you're choosing from a line segment, you should be getting the same slope each time, right? When it's a constant slope like that. So if I'm comparing these two coordinates, well, my rise is 2, run is 1, m is equal to 2. When I'm comparing these two coordinates, I still get a rise of 8 divided by run of 4. I still get slope is 2. That's the main point of this exercise, to recognize that when you're looking at two coordinates of a line segment, you're going to have the same slope regardless of which two coordinates you're comparing. So what are your observations about the slope of one step versus the slope of an entire staircase? Well, it's going to be the same. You're dealing with the same slope. So slope is the ratio of rise to the run, m equals rise over run. The slope of part of a line segment is the same as the slope of the entire line segment, is what we found. So what is the slope of the following line? So I am noticing that, all right, so I see a rise. So 1, 2, 3, 4, a rise of 4, 1, 2, 3, 4, 5, and a run of 5. So when we put that together, we have slope is equal to 4 over 5. Revisiting our investigation, which line has a positive slope and which line has a negative slope? And so in our version, ours was a bit steeper. Anywho, the which line is a positive slope? Well, this is a negative slope. It has a downward trend. Line is moving from left to right. It's going down, and for this one, it's going up. It's a positive slope from left to right. All right.